welcome to CodeStack Meetup. My name is Zack Schuster, and today I'm going to be going over Git. Before I begin, I just want to say that if you want to view these files for yourself, you can go to github.com/codestacksj/codestack_meetup, and if you go to the 009-Git presentation folder, you'll be able to see all the different things that we're going to be going over today. So, what is Git? Well, Git is essentially a special file system for keeping track of changes. Well, what do I mean by that? Well, if you go to your actual file system that's been provided for you, you can see, you have your different volumes and you have your different folders and things of that nature. Well, let's go into our actual presentation folder where I have all these files. And you can see all of them right there. Now, this is itself a Git repository. And if I reveal my hidden files and folders, you'll be able to see this .git folder right here. And what this .git folder has is another set of files and folders that contains in them all the different changes that you've made to your files that Git has taken care or kept track of for you. And today we're going to go over some of what's in this folder, but for the most part, how to tell Git to manage or to instruct Git how to manage what it's doing. So why would we use Git? Well, if you've ever gone to college, for instance, and you had an essay that you had to work on over multiple weeks, and you wanted to keep track of different versions of your essay, you may have done something like essay, essay2, essay2 final, essay2 final, final, etc. What Git does is it allows you to work with just that original essay file while still being able to keep track of all of those different revisions without having to copy those files and rename them. Instead, you tell Git what your different revisions are, and then later on you can go back and you can look at them and even compare them over time. So Git is what's referred to as a distributed version control system. This is separate from the earlier kind of system that does the same thing called a centralized version control system. You may be have heard of this in tools like CVS, Subversion, or Team Foundation Server. The difference between Git and a tool like that is that with a centralized version control system, you're constantly talking to a central server to get permission to pull files out to modify. This concept is called checking in and checking out files. And when you're working on a file, nobody else can work on, and if you're working with other people, nobody else can touch those files as well. What Git does is it allows you to copy all of the files to your local file system and to any other computer that wants to have a copy of them. And everybody can work on those files independently without affecting anyone else. And then later on you can worry about whether or not those changes that people are making have conflicts with each other and how to resolve them. Git is the most popular kind of this system, but you can look up others by searching for distributed version control systems. And you'll find Mercurial is the most common, but there are others out there as well. So we're going to have 5 different sections, 5 different parts to this presentation. First is we're going to go over some of the important concepts, the things that you need to at least have a baseline grasp of if you want to use Git effectively. Next, we're going to be talking about setting up your computer, setting up your repositories, how to configure Git and configure your repositories. Next, we're going to be talking about making commits, commits and repositories being one of the concepts we'll go over. And then finally, we're going to be talking about how to work with these commits and work with these repositories. So let's start with the important concepts. Well, the first is, as mentioned before, it's a commit. Now, a commit is little more than a container for one or more changes. If you're familiar with video editing, for instance, or video file formats, you might be familiar with the MKV format. MKV itself is also a container format, and what it does is it allows you to put many different kinds of files into one representation. So when you have an MKV file, you could have an MP4 inside it, as well as an MP3, as well as a set of JPEGs, etc., etc. The important thing to know here is that the container is a single representation, but it can have many different things inside of it. So with a commit, it's the same thing. Now, it is a way of representing one or more changes that you've made to the files that Git is keeping track of for you. And what this commit does for you, in addition to packaging all these changes together, is it also keeps track of some data about who did something, when they did it, and if they included a good enough message, what they did and or why they did it. Now, the important thing is that when you're looking up these commits, you're not looking them up by any sort of like human readable term, if that makes sense. You're looking them up by something called a hash. Now, a hash, this is exactly the same as a password hash. If you don't know what that is, whenever you log into a service, be it Facebook or Google or YouTube or whatever, and you put in your login details, your username and your password, and they get sent off to the server, the saved part of those login details on their end in the database is not saved the same way as you input it. Instead, it's run through this mathematical function called a cryptography function, which I should mention has nothing to do with Bitcoin. But what this does is it takes your data and it transforms it into basically a bunch of gobbledygook with some really solid math behind it to say that this data, essentially, the string that it gives you, represents the data that was fed into that function. Now, Git specifically uses a function called SHA-1, and that's soon going to be replaced by another function called SHA-256. The important thing to know about that is that these functions always produce hashes of the same length. So if you put in a change of a single character, changing an A to a B, for instance, it's going to produce a 40-character commit. If you insert the entire copy of War and Peace into a file and you send that to a commit, it's going to produce another 40-character long string. And what that does is it gives you kind of an address for you to look up what your different changes are. The other important thing to know about this hash is that the data it's feeding into it isn't just your changes, but it's in fact the entire file structure at the time of your commit. So if I make a change to this concepts.md file, for instance, if I change hash to hashes, it's going to take the data from the file at that time with that change to hashes, and then it's going to take all the other files that I have here, and it's going to run them all. It's going to take all of that data and put it through this function, and it's going to produce that 40-character hash. And what that does is it practically guarantees that Git can store a reference to a file system at the time of the commit without conflicting with anything else. So the next part of this is called a branch. Branch is just a name for a set of commits. The default name is master, though I believe that's changing now. There's been a lot of talk lately of changing it to things like main or whatnot, but for now the default is master. You can change that yourself, but that's kind of an advanced thing. Branches themselves, if you look at the Git folder, they're stored right here, and they're just a text file that, if you look at it, just has a hash inside of it, and that right there is what a hash looks like. So the important thing to know here is that branch isn't anything particularly special on its own. It's just a reference to the latest commits that you have set up that branch to reference. The other important thing to know is that deleting them is a bit weird. We'll go over that a bit later with git checkout and git branch with some of these commands that for working with commits and repositories. The next thing is the index. Now the index is that .git folder that I referenced before, and this is where Git keeps track of all of your commits. The important thing here is that literally every piece of your data that you have put into your repository gets stored in this Git objects folder. So if we look at it ourselves right here, you can see all these different folders with all this different weird kind of naming conventions on it. Well, that's because Git has a lot of different tricks for keeping track of your data so that it doesn't have to duplicate it as much as possible. But it does actually copy all of your data in there. So if you put, for instance, a 50 megabyte video file in there, it's going to copy that 50 megabyte video folder into that objects folder. And so your repository will effectively grow by 100 megabytes. And the other important thing to know is that you don't actually touch this file system yourself. You kind of have to just pray to the terminal and give Git commands to modify it. And then Git will interpret your commands according to its own processes and do different things. Next concept to know is called the staging area. The staging area is where you group changes together to eventually become commits. This one is important to know because when you're, this is one of the more confusing parts of Git for a lot of people, because when you're setting up these different commits, you actually have to do multiple different commands in order to package them together. Other systems, Mercurial is, for instance, makes this a lot easier by just having, for instance, just one command for doing this. But Git breaks it up into different commands, mainly to try and give you more granularity of control over how you put these commits together. But the important thing to know is that you don't just add files to commits directly. Generally speaking, you have to put them into the staging area, and then from there you can instruct Git to make them a commit. And then finally, the last concept is the working tree, and the working tree is just the files you're currently editing. So if we look over here at these files on the left, this is literally just my working tree. And this will usually, if not always, be based on the file structure at the time of a given commit. So if I decide to go back and look at an earlier commit where one of these files was missing, this file would disappear from my working tree. And all these concepts together, these make up the essential parts of a repository. So how do we configure a repository? Well, first of all, we need to install Git. The easiest way to do that is to download an installer from the Git homepage, which is at git-scm.com, right here. You can see the latest release here is 2.27, but there is another release for Mac that is a few versions behind. I run on Mac OS. This presentation is being given on Mac OS, so that's why that's appearing for me. But if you're on Windows or Linux, you should be able to download the later version. If you don't want to do it that way, you can also usually get Git through Git desktop clients like the GitHub or I believe Git Tower or the Bitbucket clients would be able to or would have Git bundled with them. And then on Mac OS, if you use their command line tools package, which you can get from running xcode select install. You don't need xcode installed for that, by the way. It'll also give you Git. And one of the benefits of doing that way is that you actually get a slightly newer version of Git than the one that's officially available through the website. So after you've installed Git, then you need to worry about customizing Git behavior if you want to. The way you do that is you put a Git config in your home folder. So if I go to my home folder, for instance, which on Mac OS is /users/ the name of my computer, the name of my account. Similar, it's C users account on Windows. And scroll down, you can see this Git config, which has tons and tons of different options, most of which you don't need to know about. And if you look at it right here, it can be kind of confusing because it's like, what are these different things doing? Well, the only really important thing that you need to know at the beginning is that you would want a Git config so that you could set up your name and your email so that when you create your commits, Git identifies you uniformly across your repositories. If you'd like to look more into customizing Git, you can also go to git-scm.com and you can look at their Git configuration section of their website, which includes a lot of different details on the different things that you can do. Next thing you need to do after that is if you're choosing to store your repositories on an external server like Azure DevOps or GitHub or anything of that nature, then you need to worry about authenticating with that server. You have two options here. The first is to rely on the operating system to handle your HTTPS security tokens for you. And the other is an older, more widely supported method called SSH authentication, which entails setting up some files in an SSH folder in your home folder. There's a handy guide on GitHub for how to do that. That will take you through the different steps depending on your operating system. The important thing though is that this is not exclusive to GitHub. You can do this with practically any Git server provider, practically all of them except SSH. In fact, I'm not aware of a single one that doesn't. All right, after you've taken care of that step, now it's time to actually work with a Git repo. So there are two different ways. You either can create a repo by going into a folder and opening up your terminal and running git init, or using your equivalent editor commands. I'm going to be talking as if we're from the command line because that's what Git was designed for, and that's how I usually do it. But pretty much every editor with Git integration has capabilities of running these commands for you. And you can look into it for your editor of choice if you'd like to, for how that's integrated. So you can either go into a folder and run git init, or you can go to the folder that you want to contain your repository and you can run Git Clone along with the URL that points at that repository. And when we go to the working repository sections, we'll go a bit more into detail about that. And that's really all you have to do to create or fetch a repo. And then the last thing you want to do is you want to hide some files and folders from Git. Git is very eager about keeping track of changes. It'll keep track of basically everything that you put into that folder. If you're a programmer and you use tools that generate code for you, whether it's like if you work with Node.js and NPM and you install modules to your Node modules, or you work with a compiled language like C# or Java, where you have these binaries that are created on demand and these different manifests that are stored in the obj folder, you would want to keep that stuff out of Git because it changes really often. It's almost always generated. Completely uninteresting stuff to track. You're not really touching that code yourself. It's just something that your tools are doing for you to help them make the code or the process of writing code easier for you. And it just clutters up your Git repository with a lot of extra data that would slow things down. So the way to do that is to use something called glob syntax. There's a Wikipedia entry that goes into detail about the syntax of globbing, essentially. As an example, here's the git ignore for this one. I've included node modules in bin and obj, but I've also included t.all files, which is like if I want to just type something out really quick, like I want to type a little note for myself, or if I am trying to write a script real quick to do something, then I can write that out right there, and Git will essentially ignore them. It'll say, okay, well, you put those files there, but I don't care about that because you told me not to care about it, so whatever. So if anybody else clones this repository, they won't see any of this data, and you won't accidentally push this data up to your repository, or to your server, I should say. And then also there are other files, for instance, the ini files, like desktop.ini on Windows, and then the .dsstore files on Mac OS, which are, again, generated by the operating system. And then I've also ignored all sorts of log files. So anytime there's like an error that a tool writes to a log file for you, for instance, Git will ignore those as well. All right, so now we're ready to talk about making commits. So making commits, fairly simple actually, but like I said before, it's broken up into two steps. The first is Git Add. Now what Git Add does is it groups these changes together so that eventually you can commit them. So the common use for this is Git Add and then period, which adds all of the different changes. But you can also add only tracked files, which are files that are already stored in a commit with git add-u, or you can add changes line by line with git add-p. And there are many other ways to interact with files through git add. You can add a single file at a time, for instance. But most of the time, you're going to be wanting to do something like git add period. After that, those files will then be in the staging area that we referenced earlier, and then it's time to run git commit. Now git commit will permanently store these changes. When you do git add and you put them into the staging area, it has not yet been copied to that git folder. But when you run git commit, give it a message and such, it will store them all there. So that's kind of the way that Git breaks it down. It says, okay, Git says, I want you to put these things in the staging area, so I'm absolutely certain what you want me to work with for the commit. And then I want you to run the command that says, okay, I'm ready for you to bundle all these changes into your commit container. And one thing to keep in mind is that you have to have a message. So if you try to, so I'll make a quick change here, for instance. I'll just add a exclamation point there. You can see now Git has noticed that I've made that change. So if I do git add period, now it's in my stage changes area, which is my staging area, which we can see if we run git status. There's my changes to me committed. If I run git reset, now that change is no longer there, or that file is no longer staged. If I refresh things over here, it's right back there. But we'll go here and we'll do git add period, or git add period, and then we'll run git commit. And if we run it without a message, it'll actually put up a little editor there for saying, okay, we want you to give us a message. And if I say, no, I don't want to do a message, it'll say, sorry, we're not going to do a commit for you unless you do a message. So you have to have a message with every commit, but the message doesn't have to be good. You could literally just do a single character, and that's and Git will accept that as a commit message. You are also able to combine these two different steps together. You can do that with git commit -am. However, this only works with tracked files, similar to git add-u. So if you're working with untracked stuff, if you're like adding new files and you want to include those in a commit, you would have to run git add on those files in order to get them into your staging area in order to run git commit on them. So after we've actually made these commits, now we need to actually worry about working with them. So there are a bunch of different ways of working with them. This is the bulk of what you're going to be doing in Git, is running these different commands. The first one to note is Git Log. So Git Log is how you actually look at your different commits and to see the different data that we talked about before, the who, the what, the when, and the why, etc. So if I run Git Log -5 right now, you can see I have a bunch of commits, chores, fixing things, and whatnot. And if I take one of these commit hashes right here, that 40-character string I mentioned before, and I do git show like that, that will show exactly the changes that I made. And you can see right here, these green lines right here, those are the lines that I added to my gitignore file. Hence why I made the message chore update gitignore. Now if I do git log -p, and you'll notice even if I included the other, or back up a second, git log -p, it will show me the commits, and then it'll show me the commits before that. So it's an interactive way of going and saying, okay, how many changes have I done over time? What have those changes looked like? And the important thing here is that this will go all the way back to the first commit if you let it. But this is a way of going, okay, so what have I done per commit? Well, in this commit, I've added these things to my git ignore. And this init commit, oh, that's when I added my editor config, added my git ignore, added all this different data. Now, you have a lot of options besides that for looking at earlier commits. The ones you probably want to know about are for looking at a range of commits. And what that means is, okay, I want to know not just I want to look at not just the range of commits for, or sorry, not just look at the commit details for a single commit, but I want to look at them for, say, 5 commits, for instance. So if we go back and we do Git Log, and we have our SHA there, and we do -5, uh-oh, well, we don't actually have 5 commits that we need to work with. So let's instead, we'll go back to our Git Log, and we'll pick this one right here. We'll pick the very first one. Now we'll go back 5. And we can see that 5 commits before that is the init commit. And then if I did that, I can just look at all the commits from before that. There are many other tools for doing that. As I mentioned, you can view more about that from the Git website again, from gitstm.com. And this is where they'll go into much more detail about using things like, oh, how do I change the format of how this gets printed out and things like that. And there's a lot of different stuff there that you can get into for basically many different ways of getting this data out of Git and presenting it either to yourself or to others. So, all right, so now we have our commits. We can view them with Git Log. We can use Git show in order to take a commit hash and see what those changes are. And then we can even use a little extra syntax in order to look at a set of commits before a certain point of time. Well, now we want to send our commits to the server. And to do that, we just do Git Push. The first time you run Git Push, you probably need to do something like this, Git Push-U origin master. That's if you've created this repository yourself with Git init and you're just setting it up with a remote. That will set it up so that you can track, or so that you can push it automatically to whatever server you want. You can actually have multiple servers that you work with in Git to store your changes. For instance, you could be sending your changes to both GitHub and Azure DevOps from the same repository, and you would use the Git remote syntax to work with that. But we'll get into that more when we get into working with repositories. For now, all you need to know is that once you do have it set up, and usually if you clone a repository, you don't need to worry about that. You just have to do Git push once you've done your commits, and it'll send it off there for you. And if you don't have anything to do, it'll be like, hey, everything's up to date, we're good. Now, that's after you've sent your commits to the server. Well, what if you need to get some changes that you don't have? Well, once again, Git has broken this up into a few different steps. The first is Git Fetch, and what Git Fetch does is it's kind of the inverse of the Git Add, Git Commit kind of thing, where Git Add will update the staging area without affecting Git's index, its special folder. Git Fetch will update the special folder with all these different changes that you don't have, but it won't update your staging area or your working tree. In order to do that, you would need to run one of these commands before. But before we do that, I'll point out that you can only get changes for the current branch by just running Git Fetch. If you wanted to get changes, if you have multiple branches that you're working with, and you want to get the changes for all of them, then you would run git fetch --all. And then if you just want to see more details, or if you want to see more details along with it, doing all branches, you can add the -v right excuse me, that right here. After you run Git Fetch, you have two different choices. You can either run Git Merge or Git Rebase. What Git Merge will do is essentially it applies the fetch commits to your local file system if you don't have commits to push. If you do have commits to push, it creates kind of this extra, pretty much useless commit, at least as far as I'm concerned, where it'll just say, hey, you merge this data in, or you merge these commits in, which is like, hey, thanks. I knew that. I ran the command, right? These can be useful in a team setting if you're following a certain kind of protocol, but for the most part, at least in my experience, you don't really need this commit. And instead you want to avoid it as much as possible because it kind of creates a mess of things. Or it can create a mess of things, I should say. If you want to run Git Merge and you don't know if you have any commits or not, and for some reason you don't want to run Git Status, Git Status would in fact tell you how many commits difference you have. This branch, for instance, is completely up to date, so there's no differences. But if I were to get rid of a commit, it would from this repository, for instance, by running Git Rebase. And I can go and say, okay, I don't want this commit anymore. Now if I run Git Status, it'll say, oh, I'm behind by one commit, and hey, this can be fast forwarded, which is what this FF only means. It means fast forward only. So instead, if say that I made a change here, and I'll do another little exclamation point right there. Git picks that up. So I'll do a git commit -am, and just because this is a test commit, I'll do an A right here. And then I run git status again and say, oh, we've diverged. We have 1 and 1 different commits. So now if I try to run git merge ff only, it's not possible to fast forward because we have different commits. So instead, I'll go back, drop this fake commit I did. And now if I run git merge ff only, there we go, we're fast forwarded. Now instead of running git merge, you can run a command called git rebase. Now if you noticed just now, I ran git rebase in order to edit my commit history to drop some commits. But it's also a useful way of fetching commits from the server when you do have commits that you need to push, when your branches have diverged in some way. So say that I'm working here normally, and I'm working alongside somebody else who's in their office or in a different state even, and we're both working on the same thing at the same time. They push up a commit, I create a commit, and I go to push it up, and it goes, uh-oh, there's a commit you're missing. Well, I can't run git merge because it can't merge things, or it'll create or it can't fast forward that merge, or it'll create that extra commit that I don't want. Instead, I'll run git rebase, and what that will do is it'll actually pull in the commits from others, and it will replay them as if replay the commits as if they were happening in real time. So what that ends up doing is ordering your commits according to when they were committed, as if they were all working on the same computer. Important thing to note here is that you probably don't want to add any other options or flags. Git rebase is very, very powerful. But you probably only want to do like the normal git rebase or the interactive rebase, or if you have some changes and rebase says it can't do anything because you have those changes, then you just do auto stash in order to literally put those changes into a stash, which it'll then take back out of when it's done doing its rebase. But a lot of these other options you can get into, that's when you start getting into the really, really dangerous stuff for losing data with that command. Now another option that you can do that I'll just mention is called Git Pull, and what this is it's a shortcut for running Git Fetch followed by Git Merge or Git Rebase, and this kind of depends on Git's mood. You can configure it to kind of always lean on doing the rebase, but in my experience that hasn't been the most reliable. I think this personally has too many trade-offs, and the only benefit is that you get to type slightly less, and that's if Git Pull works correctly. But a lot of people, they really do like working with Git Pull. They'd rather work with that than worrying about whether to use fetch and then merge or rebase. They'd just rather run the one command and be done with it. So I'm including that there as well. And one last thing I want to go over that I didn't touch on was say that you're working with a branch and you have some changes and you push them up there, and then you're like, you know what, I want to change that, but I don't want to create kind of like a paper trail, like a commit history of all these different changes. I really just want to treat these changes as one unit. Well, then you can use Git Rebase in order to squash all these changes together or fix them up, make them into one commit essentially. And then you can use a command called Git Push -f, which allows you to force push the current state of your branch. So in my earlier example, where we're talking about two different people working on the same branch or same data, when you created your commits and you tried to push it up and it said, oh, you're out of date, you have to pull down this other commit. You could do a Git Push -f, which would force your changes up there, but it would also completely erase any other commits that you don't have locally. So that's why that exclamation point is there, is because if you're force pushing into a shared branch, especially if you don't know if there's any changes on there, it's very likely that you're going to delete data that you don't want. So a slightly less dangerous version of a force push is called force with lease. That will tell you, oh, okay, there are commits from other people. We're not going to do a force push for you. Versus, oh, it's just your commits that we're overwriting. We don't care. That's why we're force pushing, is because we want to overwrite our own data. So it's fine. And that's how you work with commits. Now, finally, we're going to talk about working with repositories. So as before, we mentioned Git Clone with a URL, and this is what the URL format looks like. So if you wanted to, for instance, clone the CodeStack meetup repository, you could just copy this as well, or you can go click on this and you can say, okay, I want to copy this SSH URL right here, or if you prefer to use a HTTPS, you can copy it that way as well. After you've cloned the repository and you've worked with it a bit, you might find that you actually do want to go look at the file structure at a given commit. So say that you've been working for a couple of weeks on something and you're like, hey, you know, I made a lot of progress here, but I kind of feel like I've lost sight of something or another. Let me go back in time and look at what I was doing when I started, and then maybe that'll give me some perspective. Well, in that case, you would run git checkout, and you would run that with either, say, a branch. Say you want to say that you've branched off from the master branch to do your work. Well, okay, I'm going to look at the master branch and see what's there and compare it to what I'm doing, or at least look at it. Or you can use a commit to do the same thing. The important thing is that when you check out a commit, if you don't include this -b flag, it puts you into something called a detached head state. And what that means is that you can work with all these files and you can do all sorts of things. You can even commit, but those commits are kind of like in a phantom no man's land where Git knows they exist, but it doesn't push them up to a server or anything like that. And it can be really hard to get that data back out once you check out to an actual branch. So if you're intending to look at stuff to modify it, not just to look at it, then in that case you want to include that -b option, and then you would give your branch name. So for instance, if I'm branching off from master and I want to create a Zack Schuster branch, I would do git checkout -b Zack Schuster. Or if I wanted to do it from a specific commit, I would do git checkout -b Zack Schuster, and that would include the reference to the commit. And one thing I want to point out here, if you notice, is that I only have 6 characters here from that 40 character commit length that I mentioned before. Turns out one of the neat features of Git is that they're able to look up these commits by a shortened version of that that commit that you have, or that commit hash, I should say. So if you don't want to type out the whole thing, or you only have a shortened reference to it that you can work with, you don't need to go to the trouble of fully expanding it. As long as you have at least 6 or 7 characters, I believe it is, you should be fine. It'll be able to look it up just fine. Next thing is how you would work with the branches themselves. So you want to view a branch, you want to rename a branch, copy it, delete it, etc., etc. These are all for local branches, by the way. If you want to work with server branch, you would use Git Push, which is you would do Git Push -d, and then the server that you're working with, origin. Origin can be is the name of the remote. It can refer to your GitHub repository, for instance, or it can or any other repository, any other server that you have set up. And then you would include the name of the branch that you want to delete, and that'll delete it on your server. But if you want to work with it locally, you would use Git branch. Now, Git branch, you can view all branches with Git branch -v. So if we do that right now, I just have the one branch, and it's right there. If I wanted to rename a branch, I can do that with Git branch -m. So I'll create a new branch right here, the -b option. And then I'll be like, okay, you know what? I don't like that it's named Zack Schuster. I want to name it Zack Schuster. So I'll say, okay, Git, rename the Zack Schuster branch to this new name that I've set up. And now if I look at all my branches, you can see my rename is right there. Well, let's say I wanted to just copy a branch. Then I can do Git branch -c, and then I will say, okay, I want to take this branch right here, and I want to copy it to a Zack Schuster branch. And if I look back up at my branches, you can see that both of those are now there. And then you can delete branches locally with Git branch -d, similar to Git push -d. So if I do Git branch -d Zack Schuster, and I do Git branch -v, we're down to that single branch. Now the final thing is, with working with repositories, is Git Rebase once more. Now this is this is a more advanced use case. This is when you want to make one branch's history the base for another branch. What does that mean? So say that you're working on a private branch, and you've been doing this for quite some time. And while you're doing this, you have, for instance, 2 other branches that people work with. You have your master branch, your main branch, and that's where, in like a production environment, that's where all your code would be built from to deliver to the production environment. And then you have your develop branch, which would be for like, oh, this is code I want to deploy to my development environment for testing. Well, say that over time, these branches kind of diverge from each other, and you want to bring them back together. For that, you would run git rebase -onto, and what that will do is it'll replay those commits, including your commits to a degree, but it'll make it as if the entirety of that branch that you've rebased onto is the earlier history for you. So it's a way of kind of catching up your work with different branches' work. And then at this point, that will put you out of sync with your copy on the server, and you'll need to run a force push in order to do that. And that's essentially it. That's all you need to know in order to work effectively with Git. I hope that this presentation was useful for you. Once again, if you want to look at all this data, you can go to github.com/codestacksj/codestack_meetup, and you go to the 009-git presentation, and you'll see all of those files right there. Thanks for joining us.